All right. So, Assalamualaikum and good evening. I guess you guys can hear my voice, right? Boleh dengar? Already? Hello, can you guys hear my voice?
Yes,
Yes,
doctor.
doctor, very
Okay.
clear.
Masuk
Okay.
balik.
All right. Okay, thank you. So thank you, you guys, attend this class. Yeah, I know some of you at kampung already. But by hook or by crook, we need to continue our class lah. Okay, we need to catch up our syllabus. So for today's class, we will cover on data screening and also data transformation. Okay, I combine these two, data screening and data transformation. So as you can see in your ITEL, it's actually I have uploaded several notes, okay, which emphasize on this SPSS data, okay. Also, we have simple notes that I just write this morning. Okay, simple notes regarding the statistical test, normality, and this is the questionnaire for the SPSS data. All right. So we shall take a look on our SPSS interface. Okay. So I just share my screen so that easier for me to click SPSS data, questionnaire, and so on. All right, so we have SPSS data here. So any problem, just tell me, just unmute your mic and then let me know. So right now, we will move to the very first step, which is to check whether there is a missing data. Okay, so actually, if you can see in ITEL just now, I put the cartoons there because we want to know the step. First is checking for the missing data, and then what else? Compute the data, and then assess for the normality. Okay. So first, we check whether there is a missing data in our SPSS or not. Okay, first, what we need to do is we click on Analyze. I just showed to you. Okay, so we click on Analyze, and then we go to the Descriptive Statistics. Okay, this is your data. You have your data, and then what we need to do is check for the missing data. So first, we go to the Analyze, Descriptive Statistics, and then to the frequencies. So just click. Okay. Wait up. Where is my Microsoft Teams? Okay. So you can check any items here, whether we have missing data. So what we need to do is you just on your keyboard, okay, on your keyboard, I cannot show here. On your keyboard, you just press Control A, meaning you just select all. Okay, so Control A, you select all, and then move to the variables because we want to know whether there is a missing data. Is there any respondents did not respond to your questionnaire? So we want to know that, right? So after that, what we need to do is click on the statistics. Okay. What you want to know here? If you want to know kurtosis, skewness, just click. Okay, but for me, I just want to show to you whether there is a missing data or not. So I don't want to know regarding the mean, mode, median. So just okay. All right. This is the analysis. Okay, come out from your instruction just now. So from the first table here, you just look at the first table. Okay, so look at the end here. Okay, I know it is quite small because this is SPSS output, so quite small. So end here meaning your number of sample. Okay, so how many number of sample here that you have? 45. Okay, so meaning there are 45 respondents, okay, involved in your data. So missing. You can see here, okay, the word missing, meaning if there is a number here, maybe 1, 2, 3, and so on. So meaning it shows how many respondent or how many data that missing from each of your items here. So you have uh, uh, gender, starting from gender, okay, the first item. This item is actually from your questionnaire, if you still remember, okay, gender up until your construct or your item for your construct A4, okay, A number 4 here, okay. So we need to take a look on the value down here, 000. You can see my cursor here, 0000000, okay, until here, 0, all zeros, okay, meaning there is no missing data, okay. All respondent respond to your questionnaire, no missing data, okay. If no missing data, so it's good lah, it's a good sign, okay. So that's all for the missing data, very simple, okay. So none missing. So what we need to do, I don't want to save here, I don't want to save this output, I just close. So I don't want to save, no. So we come back to this data view, okay. So we have done with the missing data, no missing data. If there is a missing data, okay, if there is a missing data, for example here, I just delete one data here. Okay, so this is number 3. So I remember lah, number 3, then. So I delete here. So what if there is a missing data? Okay. We do it again, analyze, descriptive statistics, and then frequencies. Okay, so all items that you want to check already here under the variables, and then just click OK. Now, again, okay, the same table, missing here. Okay, missing here. If you can read from here, 0000, and then suddenly under items E4, number 1. Okay, meaning one data missing. Okay, so we have one data missing. So it depends on you to decide for this data, whether you want to save this data, okay, meaning you want to rescue this data, you don't want to delete them, okay. So maybe you need to contact back your respondent, okay, if you are able to do so. Otherwise, you just delete the data lah. Okay, you just delete the respondent who did not respond to your item. Okay, so this is how it looks like. Okay, number 1 meaning one data missing. Okay, so close this. I don't want to save. Come back to the missing data. Number 3 just now. Okay, all right. So that's all for the missing data. Okay, so clearly there is a evidence and it is clearly stated no missing data. Okay, so done for missing data. Okay, next, what we want to do is we want to compute the data. Okay, compute the data. All right, so how? The data that we want to compute is actually, where is the questionnaire? The data that we want to compute is actually the data from your construct. If I said construct, meaning this one, exhaustion. Okay. Second construct, burnout and engagement. This is the second construct. Okay. Third construct, professional efficiency. So if you're asking me what is this is your questionnaire. Okay, questionnaire that we distribute to the respondents. We got the response and then we do the data analysis. So this is all the construct. Siapa mau masuk ni? No one. Okay. Oops. Okay. Okay, sudah. Okay. All right. Okay. So come back to our construct just now. We have exhaustion, burnout, and engagement, professional efficiency. Uh, this one. Okay. But this is not, this is the main construct, but I would like to narrow down, okay, our view to the to the, what we call the construct here, vigor, dedication, and also the absorption. Okay. So this is all our construct. If I say construct, so you know already, this is the construct, the purple color here. If I say subconstruct or the item in the construct, meaning this one, E1, E1, E2, E3, E5, this is all the subconstruct. Okay. Now, the one that we need to compute the data is this construct. Okay. For example, the first construct, exhaustion. So all items under exhaustion, we need to compute. Find the mean under the first construct, mean for the exhaustion. Okay, so how to do that is come back to the SPSS data. What happened to this person? PT her? Waiting in the lobby. Done already. Okay, admit again. All right, so come back to the SPSS. Now, we are currently computing the data. Okay, so the first step to compute the data, no longer analyze, currently move forward to transform. Okay, this is computing the data, how we compute the data. Transform, compute variables. Okay, so we know this is compute variables. Click. Okay, then this is the pop-up. Once we click on compute variables, okay, what we need to do, first take a look on the target variable up here. Okay, we have target variables. What we need to do here, you name your computed variable. Okay, so what kind of name that you want to give? For me, I would like to give as mean. Okay, mean for exhaustion. Remember, you cannot have space. Okay, this is the downside of the SPSS. You cannot have space. Okay, you cannot read your data. So mean underscore exhaustion. Why I put as exhaustion? Because I know that this is the mean or the computed data for the first construct, which is exhaustion, right? It depends on the questionnaire. So after you give the name for your computed data, you need to take a look on the right side here. Okay, on the right side here, under function group. Okay, look at my cursor. Okay, moving cursor here, function group. And then what you need to do, scroll down, okay, until you find statistical. Click on it. Okay, statistical, click under function group. And then what happened? Look at your function and special variables down here. Okay, on the right side and down here, function and special variable. Take a look on the mean, MEAN, mean. Okay, what we need to do, double click. Okay, once you have double click the mean here, what happened? Look at to the up here, numeric expression. Okay, numeric expression. So there's a pop-up here. Once you you double click the mean. It is stated as mean in the bracket, question mark, question mark. Okay, so this question mark, what we need to do, the first question mark, replace with your sub subconstruct. Which subconstruct? Go back to your questionnaire. This one. E1. Okay. E1, I feel emotionally drained, blah, blah, blah. So exhaustion, the subconstruct is E1, E2, E3, E4, E5. Okay. So go back to your SPSS. So all the question marks here, please replace with the subconstruct. Here, on the left side here, E1. Okay, click, double click E1, and then it will replace under the numeric expression. Okay, then comma. Okay, already have comma there. So second question mark here. Replace with the second subconstruct, which is E2. Left hand side here, E2, double click. So it will replace the second question mark. What we need to do afterwards? Click, click comma on your keyboard. Okay. And then put again E3, comma, E4, comma, E5. So all the subconstruct from E1 until E5 already under the numeric expression. Okay. Okay. And then what we need to do? Done already. So down here, okay, down here we have the option OK. The blue color here, OK. So click on OK. So wait for the output. Okay. Wait for the output. Okay, already. This is computed data. Nothing will be appear here. The one that we have, the result is not on this output. You just close this output. Don't save. But from this data view, okay, down here you have the slider. You slide to the right. Slide until you found mean exhaustion here. So this is the one that you compute just now. Okay, so you have compute the data for exhaustion. All right. Okay, you guys okay? Understand how we get this mean exhaustion? Okay. Are you guys okay?
Yes,
Yes,
doctor, so
doctor.
far.
Okay,
Okay.
doctor.
Okay. So we continue with the second construct. Okay, we have a lot of construct here. Yeah, exhaustion. What else? Absorption, burnout and engagement. Okay, from B1 until B4. We have the third construct. So all of this we need to compute. So again, we do the same things. We do the same things for the second construct. Transform computed variables. Okay, now it is not exhaustion. Apalah? Burnout and engagement. So I just put burnout. Burn out. Okay, so mean for burnout. So this one you just replace. Okay, so just delete. You just replace with the second subconstruct, which is B1 until B4. B number 1, comma, B number 2, comma, click B number 3, comma, B number 4. Okay, and then click OK. Right. So as I told you just now, this is closed. Do not save, but you need to take a look on the right side here. Mean burnout. Okay, so we have the computed data for the second construct. Okay, settle for the burnout. You just repeat the same things. Okay, for all construct. Next construct is professional Okay, so professional P. So come back to the SPSS. Transform, compute variables. So right now, professional. Oops. Okay. So under the numeric expression, just delete B1 until B4, but you replace with P1 until P6. So P1, comma, P2, comma, P3, comma, P4, comma, P5, comma, P6. Okay? So this is the last one. Do not put comma afterwards. Just P6 and close the bracket. Okay? So click OK. Right. So here on the right side here, this one you just don't save, close. You have the mean professional. Okay? So 1, 2, 3. We have done with the 3 constructs. Now the next construct is this one. 1, 2, 3. Vigor, dedication, and absorption. So from here, where is the, okay, this one. So from here, we need to transform, compute variable, the same things. So you give the name as vigor just now, mean vigor. So from V1 until V5. Okay. So V1, comma, V2, comma, V3, comma, V4, comma, V5. Okay. Okay. So this one just close. Nothing appear on the output, but it is already on the data view. This one, mean vigor. Okay. What else do we have? Dedication. Okay. All the subconstruct under dedication, you need to compute. So again, the same things, compute variable for dedication. Please remember to give the name or to rename this. So this is all the steps. Okay, the step that you need to do in your individual assignment. All right. So dedication is D, starting from D1, comma, D2, comma, D3, D4, D5. Okay. So click OK. All right. Close this one, this output. You don't need this output. No, don't save. So here you have the mean dedication here. Okay. And the last construct that we have is absorption. Okay. Absorption. So starting from A1 until A4. So the last one, compute variables, is absorption. Absorption. So this one replace with the subconstruct under the absorption. So we have A1, double click, comma, A2, double click, comma, A3, and also A4. All right. So okay. Right. So this one you just close, do not save. Here. So you have all the computed data for the construct, starting from mean exhaustion until, where is the last one? Mean exhaustion until mean absorption. Okay, so you just save your data first, right? That is how you compute your data, right? Why we need to compute our data? Because it makes our life easier. You will not use one by one items here. You need to compute so that you have the mean value. Okay, the mean value for all the sub-construct under the same construct. Okay, so we have the construct. Under the construct, we have a lot of items. You need to find the mean value first. Okay, so then you can undergo the next process, which we call it as assessing normality. Okay, so up until computed data here, you have any question before we go to the assessing normality? Any question? Can you follow me up until here? Data computing data. Okay, is it okay? This is what you need to do, okay, for your individual assignment. So I need you guys to understand, right? Okay, so computed data. So done with computing data. Okay, we have all the computed data here. Now we move to the assessing normality. Okay, so before we move to the assessing normality, I just want to give to you the overview here. Okay, this is the we call it as a simple notes for you for you guys to understand why we need to learn all this analysis data. Okay, which is afterward you will learn about ANOVA, you will learn about independent sample t-test, PET t-test. Okay, you will learn about correlation, Pearson correlation, you will learn about regression. All those tests is actually underlies under parametric. Okay, we have statistical tests. Okay, the one that we learn, statistical tests, we have two kind, parametric and non-parametric. Okay, so for parametric, in order for you to run all the tests that lies under parametric, you need to have these assumptions first. Okay, need to obey all the assumption. So one of the assumption we have is normality distributed. Your sample, your data should be normally distributed. Okay, so this one we need to check with the assessing normality test. Okay, so this is one of the requirement. We call it as requirement lah. Okay, so if you can prove that your sample or your data is normally distributed, then only if you can use this analysis. So this is all analysis that we will cover in our course. Okay, you will learn about this independent sample t-test, one-way and two-way ANOVA, Pearson correlation, regression. So in order for you to use this analysis, you need to make sure one of the requirement here, okay, uh, normality test has been carried out. Okay. What about non-parametric? Non-parametric, we will cover only one analysis, which is the chi-square. Okay, which is I think like week 12, week 11, something like that for the chi-square. Okay, but most of the tests, most of the analysis that we learn, it is lies under parametric. Okay, so that's why we need to check for the normality. Okay, so come back to SPSS. Okay, so from here, how to check or how to assess the normality. Okay, first you need to click on analyze up here. You have a lot of here. Up here you click analyze. Okay, the same things, go to the descriptive statistics. Okay, analyze descriptive statistic and then explore. Okay, so analyze descriptive statistics, explore, click. We are currently assessing the normality. Okay, we want to know whether our data is normally distributed or not. Okay, so right now, the one that you need to move to the dependent list is the one that has been computed. The data that has been computed. That's why I asked you to compute the data first. Okay, so all the computed data. you need to check. Okay, but I show you one first, the mean exhaustion. Okay, I just show you one example. Mean exhaustion, you click and then move to the dependent list. Okay, so please bear in mind, to check or to assess for normality, you need to use computed data. Okay, so this is all the computed data. I give one example, which is mean exhaustion. So I move under the dependent list. Next, click on right side here, you have statistic. So click on statistics, and then we have a lot of options here. Click on outliers. Okay, you click on outliers, check to continue. Okay, so settle for statistics. The next one, plot. Okay, plot on the right hand side here, not the downside here. Right hand side, plot. Click. Okay, so there's pop out. So what happened here? We need to click. Click histogram. Under the descriptive, you have histogram. Click. And then check also under, this is normality plot with test. So two things here, histogram, normality plot with test. Okay, so done, continue. Down here, the blue color, continue. Click. Okay, what else? Just these two, statistic and plot. And then all done. Okay, you just click OK at the bottom here. Okay, click. Right now, you have an output. So this one, enlarge. Okay, we have this output. Okay, so what are we doing now is assessing the normality. All right. So to assess the normality, or to check whether our data is normally distributed or not, first you need to take a look on the value, the significant value. Under, you scroll down, scroll down until you find this test of normality. Okay, we have several methods, but the very priority one is test of normality table here. Okay, under this test of normality, okay, this is very serious, you need to listen carefully. Okay, so under this test of normality, we have two tests here. Okay, on the left hand side, we have Kolmogorov-Smirnov. Okay, Kolmogorov-Smirnov. On the right hand side here, we have Shapiro-Wilk. Okay, now, which one we need to take a look? Kolmogorov-Smirnov or Shapiro-Wilk? Please refer to the notes that I attached in the ITEL. This one. Okay, normality in SPSS. Okay, I already cite the reference here. Okay, so we don't look at the skewness and kurtosis first. We skip to the Kolmogorov, Kolmogorov-Smirnov and Shapiro-Wilk. Okay, now I asked you just now which one we need to use, the Kolmogorov or Shapiro. Okay, please read here. Number one, use with sample below 300, meaning Kolmogorov and Shapiro, you need to use this test if your sample below 300. So number two, for sample larger than 300, they may be unreliable. Okay, so this is the facts. Okay, number three. Okay, number three, for Kolmogorov-Smirnov, can be used if your N is what? Number of sample. Okay, if your number of sample equal or more than 50, this is the sign equal or more than 50. If you still remember how many sample size that you have, let's take a look. If you forgot, then refer back to your data. So from here, you can have your data as well. N, okay, under the case processing summary, you have N. As I told you, N is sample size or number of your respondents. So 45, okay, 45. So go back to the notes just now. What happened to the participant now? Okay. So go back to our simple notes just now. For Kolmogorov, it can be used if your sample size equals or more than 50. But our sample size is not 50, it is 45, less than 50. Okay, so here, Shapiro-Wilk. Shapiro-Wilk can be used if your sample size less than 50. So you have your decision already. Okay, you look at the value which is under Shapiro-Wilk. Okay, your value under Shapiro-Wilk. So go back to our data, output data, test of normality. Okay, test of normality. So on the right hand side, we have Shapiro-Wilk. Okay, on Shapiro-Wilk, we have 1, 2, 3, statistic, DF, and significant. SIG dot here is significant. Okay, the one that you need to take a look is the value that lies under significant, SIG dot here. Okay, SIG is the significant value. Okay, so I repeat for you. After you have run your normality test, okay, and then you have clicked all those things that I teach you just now, and then you will have this kind of output. Okay, so on this output, I ask you to just scroll down until you find this test of normality table. Okay, test of normality table. But under this test of normality table, we have two tests, Kolmogorov and Shapiro. Which one we need to refer to? So that's why I ask you to refer to the simple notes that I gave you in PDF. Okay, so from that simple note, says that if your sample less than 50, okay, which is your sample is 45, right? So if your sample less than 50, you need to use Shapiro-Wilk test. That's why I refer to the right-hand side. Okay, so under Shapiro-Wilk, you have three numbers here. So which one? It is the significant value, the SIG dot here. Okay, so under SIG dot here, significant value, you have 0.189. Okay, so you need to just take 2 decimal place lah. Do not take this 3 decimal place. So meaning 0.19. Okay, 0.19, it means also 0.19. Okay, so your value is 0.19. So remember, we go back to the notes. Okay, so your value just now, okay, so I just write here, your significant value, which is under the Shapiro-Wilk, is 0.19. Or you can write as 0.19. Doesn't matter. Okay, so your value is 0.19, right? So what does it say? 0.19. What is this? Refer back to your number 4 and number 5. Okay, number 4 here, it says that if your significant value less than p value, the significant is this one. This is the significant. Yeah, let me draw. Okay, this is your significant value. So this one, get this value from the output of your SPSS. Okay, so that's why I ask you to refer to number 4, significant value less than p value. P value is 0.05. Okay, if your value less than 0.0, your significant value is less than 0.05, your data is not normally distributed. Okay, but if your significant value more than 0.05, your data normally distributed. So my question to you, okay, my question, this value 0.19, more or less than 0.05, more or less. This is 0.05.
It's more. It's more, doctor.
Yeah, okay, very good. So this significant value 0.19 is more than 0.05. Okay, so meaning your data is normally distributed. Well done. Okay, your data is normally distributed. So what does it mean? Here, we have the box here. Okay, so if I say P more than 0.05, okay, you fail to reject your null hypothesis. Okay, you fail to reject your null hypothesis. So how to write the report? Okay, I give you example here. You just scroll down. This is how you write your report. This is in the third assignment. If you still remember your third assignment, you need to write the report. Okay, so this is how you write your report for normality. Okay, so this is how. So just now you choose Shapiro-Wilk. So you said, okay, Shapiro-Wilk test of normality was conducted. Why? To determine whether the mean of exhaustion. This is your construct. My construct just now, exhaustion, right? So I write as mean of exhaustion. If it is mean of absorption, then you need to write mean of absorption. Okay, so what does it say? It says that your data is normally distributed. Okay, this is from this one just now. Okay, so after that, the result indicates that the study failed to reject the null hypothesis, okay, for the exhaustion data. So where is the value? So please, okay, describe the value or state the value here. Significant value, how much you have just now? 0.19. Okay, or if you write as 0.189, I accept. Okay, whereby P more or less. If more, then you write P more than 0.05. Okay, so from here, you can conclude that your data is normally distributed. This is very important, because before you run your analysis, like for example, you run ANOVA. Before you run ANOVA, we need to have the report regarding the normality first. If your data is normally distributed, then we accept your analysis for ANOVA. If you don't write this, you will lose your marks. Okay, because I don't know whether your data is normally distributed or not. Okay, so this is how you can just copy my style of writing. This is the APA style. All right. So up until here, you guys can follow me. Is it clear?
Yes,
Dear
doctor.
doctor.
Okay. So this is the Kolmogorov and Shapiro-Wilk. Now, go back to the SPSS. Okay, this is the output. We do have this table as well, the descriptive table. Okay, but I want you guys to look at the last two, these two, skewness and kurtosis. Okay, skewness and kurtosis under descriptive table. All right, so these two value for skewness and kurtosis, look at the value under the statistic, not standard error, statistics. Okay, so skewness under the statistic, we have the value 0.29. Kurtosis, we have the value negative 0.33. What does it mean? Okay, take a look your PDF. Everything's here. Okay, so this skewness and kurtosis is actually, you can refer as well. Okay, for normality. Okay, for normality test. If your value under Kolmogorov and Shapiro is not normal. Okay, So I repeat, you guys can refer your data or your output on skewness and kurtosis if your data under Kolmogorov and Shapiro test is not normal. Why? Because we need to make sure as much as we can that our data is normally distributed. So we have the option. Other than Kolmogorov and Shapiro, we do have skewness and kurtosis. Okay, but in our case just now, exhaustion under Shapiro will already normal. So no problem at all. But if your data, both for Kolmogorov and Shapiro, not normal, what you need to do is please take a look on the skewness or kurtosis. Okay, so first we go with the skewness. Okay, skewness. Number one, we read the first one. Number one, it says if your sample less than 50. So the first one is implies to our case, right? Because this is our sample less than 50. Our sample just now is 45. So we will use the first info. So sample less than 50, you need to use the Z range within negative 1.96 and plus 1.96. So to make it easier for you, I draw for you down here. Okay, you just imagine you have a straight line. Okay, this straight line we have a range. Okay, the range is starting from negative 1.96, okay, until positive 1.96. So in the middle we know must be zero lah. Okay, now your significant, your skewness, your value for skewness. Where is your value for skewness? Depends on your output here under the descriptive table. Okay, so I told you just now, skewness value under statistics. It is 0.29. Okay, go back to your PDF. Your skewness 0.29. Okay, 0.29 is for the skewness. Now, my questions. 0.29. Is it lies under this range from negative 1.96 until positive 1.96? Is it this range, this number or this data lies under this range? Yes or no? 0.29. Is it lies under this range? Come on, guys.
Yes,
Yes or
doctor.
no? Yes. Okay, very good.
Yes.
Yeah, so maybe somewhere around here, 0.29. Okay, so your data lies under this range, meaning your data is normal. Okay, so if your data lies under this range, your data is normal. Okay, so very good. Okay, for skewness. How about kurtosis? Okay, kurtosis, the same things. Kurtosis, where is your value? Kurtosis, you have negative 0.33. Okay, go back to your PDF. Okay, for kurtosis, negative 0.33. Now, you use the same range or the same scale. Negative 0.33. Okay, my question, is it this data lies under this range? Yes or no?
Yeah.
Yes, doctor.
Yes, very good. So maybe somewhere around here as well, 0.33. Okay, so your data for skewness and kurtosis lies under this range, meaning your data is normal. Okay, so very good. But actually, you already know your data is normal based on the Shapiro work just now, right? But you try to like check again with the skewness and kurtosis. Okay, but if you don't want to check, it's okay. But you want to check, then this is how you can check. Okay, the way that you can check your data using skewness and kurtosis. Is it okay?
Okay,
Up until
doctor.
here? Okay. All right. Now,
Doctor, I have a
yeah.
question.
Okay. Yes.
So what happens if the data is not normal?
If
So
the
we
data
test
is
it
not, yeah, if the
using
data
the
is not
skewness.
normal, you cannot use, okay, we go to this, okay, this one. If your data is not normal, okay, you need to use non-parametric tests, in which means that you cannot use all this analysis. This analysis that we will learn in our course, in which I will test you for your second assignment. Your second assignment, you need to use ANOVA and regression. Okay, so that's why I highlight for you that you need to make sure your data is normal, because we need to use the parametric test. The parametric test is this one, all the example here. Okay, if your data is not normal, so it will be problem for you, because you cannot, you no longer use the ANOVA and also the regression for your second assignment. That's why. But if you do the research by your own, it doesn't, no one will argue if you want to use non-parametric. But for this course, you need to use, you need to make sure your data is normal, because we need to use the parametric test. Is it clear?
Yes,
Is
doctor.
it
Thank
clear?
you.
Okay. All right. Very good. Any other questions? No? No questions? Okay. If it is no question, okay, we try the second example. So this one, how can we do? Let it be. Just we move to the next example. So this time, I want you guys to teach me. Okay, teach me how to do the normality. Okay, try to teach me. I want to check the normality for burnout. So how can I do? Can someone please respond how? Which one I need to click first? You can try and error. Which one? Which one I need to click up here? Still remember?
Go to the analyze.
Analyze.
Yeah, and then click the
And then,
descriptive statistic,
okay.
and then explore.
Okay, very good. And then here I need to go back here. Okay. So which data just now?
The burnout.
Okay. The mean. Okay. The mean for the burnout.
Yeah.
And then
Move it to the dependent list,
all right.
and then click the statistic,
Statistics.
and then
Already. Yeah,
outliers.
already the outliers. And then what else?
Continue. Click the plots.
Plots.
Yeah,
So
and then
histogram and normality, right?
yeah.
Okay. So already here. So continue. And then
Mhm. And then um, and then
and then
okay.
okay.
Yeah.
All right. So we have the result. So okay, thank you. Can we have
Okay.
someone else to interpret? To interpret. So I think we need another two persons representative. For the first one for test of normality. Okay. Anyone? You want to try? Test of normality. What we need to do? Come on. This is how you need to do the normality test afterwards within your group. So how? Test of normality. What we need to do? You teach me. How? Test of normality. What I need to do? Help
Hello,
me.
doctor.
All right.
So we're gonna check the mean value.
The
Is that
mean value.
test of normality? So depends on our sample or the numbers of sample. So we got 45. So we
Mm-hmm.
use Shapiro-Wilk.
Okay. And then we
So
have
we check
three different numbers here. Which one? Statistic, DF, and
a
significant.
significant value.
Okay, very good.
Significant value.
Okay.
And so we can see the significant value is 0.199. So we make
Mm-hmm.
it short. So we make it short to 0.20.
Okay, very good. And then?
And then we check the, so we got a test.
Mm,
Is that in range of uh
where is the,
Shapiro-Wilk?
the notes
Yeah,
here?
yeah, I need this. So, okay, so we got our significant value 0.2. So
Mm-hmm.
we can
More or less than 0.05.
so it's more than the p-value
Okay.
0.05. So that
Okay,
means
very
these
good.
data are normally distributed.
Okay, very good. Thank you. Aaron, isn't it?
Yes, doctor.
Okay, so thank you. So very good. That is how you analyze your data for Shapiro-Wilk. Okay. So again, if you have this kind of table, test of normality, okay, so you will be confused whether you want to use Kolmogorov or Shapiro. So which one you need to decide, it depends on your number of sample. Okay, your number of sample, 45. So if you don't remember, you just refer back to this. Okay, if your number of sample less than 50, okay, you use Shapiro-Wilk test. Okay, so now your significant value under Shapiro-Wilk just now is 0.20. Okay, so I asked Aaron just now, 0.20, is it more or less than 0.05? And then he said more than 0.05. Okay, so more than 0.05, meaning your data is normally distributed. Okay, very good. But okay, next, if I want to take a look my data, not on this test of normality table, but under descriptive or skewness and kurtosis. Any representative? How can I refer this value? Negative 0.32 and kurtosis 0.51. Can someone teach me? Skewness and kurtosis. Yes? Yes, please. Any representative? Ada? Yes, please. How? Skewness and kurtosis. You guys can try. Teach me how. Come on. Yes, please.
Hello, doctor. If it's okay, I can do it.
Okay.
All right, so we just find skewness and kurtosis, and
Mm,
we ignore the standard error. We just focusing on the statistic.
okay.
So we can find the skewness is negative 0.318. So we make it short to negative 0.32.
Okay.
And for the kurtosis is negative 0.513. So it's negative 0.51.
Okay.
And we use the Z range. So the
Mm-hmm.
sample is less than 50. We use the first one.
All right.
So the Z range is from minus 1.96 to
Okay.
uh 1.92.
Okay.
So we can find our both our value
It's the skewness just now
for
is
skewness. Yeah,
negative 0.32.
yeah.
This is a skewness.
Okay,
Okay, another one 0.51, isn't it?
5.1. Yeah.
All right. So how?
So we can
Skewness,
find both
kurtosis.
of these values. They
Mm-hmm.
are in range of this Z range. So that means this one is normally distributed.
So is it lies under this range?
Yes.
Yes. Okay. So very good. Okay. So that is how. Okay. You check your normal distribution under skewness and kurtosis. Okay. Very good. Thank you. So up until here, everybody, you guys understand? Can catch up until here. Is it clear? Before we end our class, is it clear? So, oh, everybody's sleeping already. Stop sharing lah. Is it okay?
Okay, Doctor.
Okay,
Okay.
Doctor.
So no question, ah? No
Probably
question?
later.
Later. Okay, so I think that's all because we have covered from the missing data, data computation or computed data, and then we covered for the data normality or the normality of data. Okay, so that's all for today. So yeah, that's all. So this class is being recorded. I'll upload later in iTel. Okay, so thank you. Bye.
Thank you so much, Doctor.
Thank you, doctor.
Thank you,
Bye-bye.
doctor.
All right.
Thank you,
Thank you,
doctor.
doctor.